everyone, my name is Annika. I'm part of the data science discovery team, and in this video today we will be doing a question on the binomial distribution. So let's go ahead and get started. So here it says, suppose you're taking a 10 question multiple choice quiz where each question has 5 possible answer choices, right? Each question or each answer has an equal probability of being correct. So in Python, assume you have imported this and this, select the line of code that correctly defines a variable d as a distribution of the number of questions you will answer correctly when fully guessing on the quiz. So kind of the first thing to decide here is what type of distribution are we dealing with? Well, here we know, well, it's going to be either Bernoulli or binomial distribution, and as we kind of mentioned in previous videos, the only difference between the Bernoulli and binomial distribution is the number of trials n that we will be performing, right? So for the Bernoulli distribution, n is just equal to 1, so there's just one trial. In the binomial distribution, n can be any number, right, greater than or equal to 1. So that's how we know that this is going to be a binomial distribution, because there's 10 questions on our MCQ quiz, right, which means that it's going to have 10 trials, right? If this was a 1 question multiple choice quiz, then we could have used the Bernoulli distribution, but since this is 10 questions, that's going to represent the binomial distribution, and this will be a binomial random variable, right? So here we know that to define it in Python, we want the parameters to be n and p, right? And we can even do this here. D is going to be represent binomial distribution where n equals 10 and p equals 0.2, because each question has 5 possible answer choices. So the probability that you get the answer choice correct is going to be 1 over 5, or 0.2. So here it looks like this answer choice makes the most sense, right? P equals 20. We want the probability to be between 0 and 1. And again, it can't be Bernoulli because it has 10 trials, and this one is incorrect because n should be equal to 10, not 0.2. So I think they flipped the parameters around. So this is correct. Now it says here, using Python in a distribution, what is the probability that you guess none of the questions correctly, right? So we know that we are trying to find the probability that x takes on the value 0, right? And if it's easier to look at it, it's kind of in a formulaic way, we can define x to be this, or you can call it d or any variable you want, right, to be a binomial distribution where n equals 10 and p is going to be 0.2, right? So when we want to find the probability that you guess none of the questions correctly, that means out of 10 questions, x is equal to 0, where x basically represents the number of questions that I got correct. So the probability that I guess none of them correctly is going to be probability of x equals 0, right? So that's going to be kind of using the probability mass function of a binomial random variable. I know it's going to be something like n choose k times the probability that p, basically p to the power of n, and then p to the power of k times 1 minus p to the power of n minus k, right? So that is going to be our probability mass function of the binomial distribution. So out of n trials, k, where k represents, this value that we're trying to find the probability of, we want to see that n choose k times the probability of k. So this is kind of going to be our probability of success, right? And then this is going to be that probability of failure, because it's 1 minus p to the power of n minus k. So when I want x equals 0, that's just going to be something like out of 10 trials, 10 choose 0 times p is going to be 0.2 to the power of 0 times 0.8, right? 1 minus 0.2 to the power of n minus k. That's 10 minus 0, so that's just going to be 10, which I put in my calculator, and that's going to give us around 0.107374, right? So this is kind of the mathematical way of solving this, which is perfectly valid, right? But if we want to do this using Python, right, we have our distribution defined here, and the kind of function that we will have to use here is going to be our PMF function, the probability mass function, right? So I want to find d.pmf, and our input will be our x value, right? So here we want to find the probability that x takes on the value 0, right? So it's actually going to be the k value, right? So that's going to be d.pmf 0, and again I got the same probability 0.10737 as I got before, right? So just want to put this here, and that is correct. And kind of the other questions are very similar, but you can either do this using Python or you can do it using our formula, right? So I'll probably just do these all using Python. So what is the probability that you guess all of the questions correctly? So I have 10 trials, so I want to find the probability that x equals 10, because I want to find the probability that I guess all of these questions correctly. So I want to find d.pmf of 10. The previous question was none of the questions, and the current problem we're on is finding the probability that I guess all of the questions correctly. So that's going to be very close to 0, right? So I can just put in 0 here if it lets me, yeah, which is the same as what we got in our Python result. And what is the probability that I guess one of the questions correctly? So that's going to be probability of x equals 1. I want to find d.pmf of 1. So that's going to be around 26%, right? Which makes sense because there's 5 questions, and the probability of success, so the probability that I guess a question correctly is around 20%. So this makes sense in our context. And what is the probability that I guess 2 of the questions correctly? Well, that's d.pmf 2. What is the probability that I guess 3 of the questions correctly? So that's just d.pmf 3. So the probability that I guess 3 out of 10 questions correct. And then 4 of them, it's d.pmf 4, which is around 8%. And that's pretty much it. So I hope this video was helpful. The main, I guess, component of the problem is identifying what type of distribution you're dealing with, and either defining that distribution in Python, right, or knowing which formula to use for the probability mass function, and seeing, given a certain value, what is my corresponding probability given this binomial distribution, right? So if you have any questions, let me know, and I'll see you next time. Bye.